So in this video, we're going to look at connecting the Thies Clima Ultrasonic wind anemometer to the Flex SCADA Flexus Q5. And we're going to start off by figuring out what the pinout of the sensor is. So we have all the wires here, and I have the manual pulled up. So let's go ahead and start browsing through the manual here a little bit and see what we can find. It looks like red and blue are power supplies, 24 volt AC or DC. And we have our half duplex interface, which is what we want to use on yellow and green. So TXD plus, minus. Some people use A, B, some people use TXD plus, minus. You can always flip it around if it doesn't work. You're not going to damage anything. But yeah, we'll kind of just go ahead and start it out, and if it's wrong, we'll flip it around. So let's get our battery. Let's throw some jumpers on here. And let's connect red and blue power connections. Red and blue. And it looks like it's powering up. I went ahead and put it into another connector here. So we have our yellow and green. So let's go ahead and connect that there. And let's connect our Q5 up to power and network. So we have A and B here and our power supply here. And sometimes we'll need a ground. We'll just see if it needs a common. It may not. It may be just fine. Let's go ahead and just see how that goes. So we have an IP address on the Q5. Let's go ahead and log into that. And so here we are on the channels on the analog input page, or device overview page. So if we go over here to logic and examples, and we go down to the very bottom, you'll see here there is a example here for the sensor. So let's just go ahead and copy that. Let's drop that in here, and let's just go over this in detail here. So on line number 2 here, we initiate the serial port. So we're using serial port 2, which is the RS485 port. And there's also a TTL port, that's just port 1, which is on the expansion port. So that's a 3.3 volt port. The RS485 volt port 2, and that's here. So we select port 2, baud rate 9600. So the manual here wasn't completely clear, but it mentioned an example here of querying the baud rate where it showed 9600. So we just kind of assume that's the default baud rate. We're not using crossovers, swapping TX or RX. That is an option there, and a one-stop bit. So we could actually even just simplify that. Just port 2, 9600 baud. And on line 5, we have our main loop here. And so you could just have true here, but there'd be no way of ever exiting this loop. And so we use run, which is just a function that returns false anytime that we command the script to quit running. And so that's if you go to change or apply your configuration, it needs a way to quit your current script. And next we have on line 8, we're making a Modbus read request. And so again, we use port 2, and so that's our serial 2. Slave unit ID of 1. So the manual here seems to indicate that 1 is the default slave ID. It's not very clear on that. It's usually 0 or 1, or it's hopefully stated on the equipment. And so we use a unit ID of 1, function 4. So the manual does list a series of function codes that can be used. I believe that's function 3 and 4. Commands, read input register 4 and read holding register 3. So we're using function 4, 3 would work probably in place of that as well. And if we look at the manual here, under the register table, there's 2 register tables on the device. One is by type of measured value. It goes from basically register 3 to 49 something, and then there's an unbroken sequence that starts at 5001 to 9999. And so we will refer to the second set, which starts at 5,000. So right here. So our first register is going to be the mean wind speed, mean wind direction, air temperature. And so we want to read, I went ahead and put in 30 registers starting at 5,000. So that would read us up to the brightness level. So everything here would be red. Additionally, you can see here that some of them have a multiplier, some of them are unsigned 32, some of them are signed 32. And so you'll notice here, this is register 1, and then there's, next one is 3. So there's actually 2 registers there. And that's because Modbus registers are 16 bits, and this is a 32-bit register. So each of these values are actually taking up 32 bits, or 2 Modbus registers. So if you're familiar with the Modbus protocol, you'll understand how that works. But you'll notice a few things here. These have different multipliers. Some are signed, some are unsigned. The Q5 has a very unique way of dealing with this type of data. There's multiple ways you could deal with that. If we look under binary data structures, you can just do a simple array of, say, float 32, or that could be unsigned 32. It could be an array, and that's super convenient when it's all one data type. When you have mixed data types, the read buffer is by far the easiest way to do that. So we'll set this up. We're initiating a read buffer with this data. So I guess I'm getting a little bit ahead of myself. So we've set up our Modbus read function, reading 30 registers, starting at register 5,000. We're using command number 4, and we are reading from serial 2, which is the RS485 port, and unit ID of 1. And if there's no error code indicated, if the result from that Modbus read function is successful, then we initiate a read buffer with the result of this read operation, so return.data, and 0, it's the offset that we're using. And so first off, we'll parse this data out. So mean wind speed, we'll see in our manual here, mean wind speed is the first there. So we go ahead and pull an unsigned 32 value there, unsigned 32, and you can see it's value divided by 10. So you go ahead and pull that unsigned 32-bit value, divide by 10. You'll notice we've also defined the byte order here, DCBA, and we only need to do that for the first value unless that changes. So in this case, they're all following that byte order. Usually once you've worked with a specific manufacturer, a specific product, that won't change, but across multiple manufacturers, you'll often encounter different byte orders. So mean wind speed is our first 32-bit sequence. Then we have mean wind direction, air temperature. So you can see mean wind speed, mean wind direction, air temperature. So what we're doing is we're creating a JSON or a object, a JavaScript object here basically with all of these members here, and we're reading these back as we create that. We're pulling this data from our buffer. So you can see here some of these relative air pressure and absolute air pressure. Those are divided by 100. Again, we're just kind of following that same sequence there. So you can see some of these, it's pulling it as a signed 32, some of them as an unsigned 32, and yeah, so we're basically creating this data structure here. So if we go ahead and run this, and we'll see here, there you go, we have data. And so that's being read from the device over RS485, and it's just printing out that structure. And what we could also do is we could also make a web server just to make this data accessible. So if we do, let's call it data, just somewhere to store our data, and then we could just, and http.handle function request there, return string data. We're just going to return our data string, and should do it. Not using the request data. That's totally fine. We don't need to do anything with that. You can look at our HTTP request video for more information on that. But let's go ahead and run that example now. And let's go ahead and put this in here. There you can see we've just made a web server now that's serving up the Clima Thies data. So that's just showing a really useful functionality where you can integrate with a device over RS485, and then you can make that data accessible over a web server. or you could send that data to your own web server. So you could take this data and you could make a web request and you could upload this data in either a GET or a POST request to your server. Again, you know, one or two lines to do everything you would need to do. And so it just makes it super straightforward. And that concludes our video on integrating the Clima Thies ultrasonic wind sensor. If you have any questions, feel free to reach out to us on our website, fluxgata.com, in the contact section. Thank you for watching.